a 202-mile-long river in North Florida comes to a sudden and complete stop. Not dammed, not diverted, not evaporated. It pours itself into the ground through a single fissure in the earth, leaving behind an empty channel of pale sand and exposed tree roots. For most of the year, a 20-mile stretch of the Alapaha River in Hamilton County, Florida, is simply gone. All of its water, a flow that originates deep in south-central Georgia, vanishes into a geological feature known as the Alapaha River Sink. Locals in the nearby town of Jennings, population 833, have watched this happen their entire lives. They see a full dark water river flowing south, and then, without ceremony, it ends. An empty bed stretches on toward the horizon. Curious what you think about a river just vanishing like this. But here's the detail that tells the real story. The water does not simply disappear. It is taking a shortcut. A secret 10-mile journey through a hidden subterranean world. The old mystery was always where it went. For 100 years, that question lingered. But that mystery has been solved, and the answer has uncovered a new, far more dangerous question, one that implicates the drinking water of millions and the future of one of the most famous rivers in America. The strangest part is not that the Alapaha River disappears. It is what is disappearing with it. To understand what is happening in Hamilton County, you have to look down. The entire state of Florida sits on a massive platform of porous limestone, a foundation formed from the skeletal remains of marine life over millions of years, back when this entire peninsula was the floor of a shallow, warm sea. During the Miocene epoch, roughly 23 million years ago, layers upon layers of coral, shells, and calcium carbonate sediments were compressed into the rock that now makes up formations like the Hawthorne Group. This limestone foundation is, by its chemical nature, soluble. Rainwater, as it falls through the atmosphere, absorbs carbon dioxide, forming a weak carbonic acid. Over millennia, this mildly acidic water has percolated down into the limestone, dissolving the rock along cracks and fissures, carving out an immense three-dimensional labyrinth of caves, conduits, and passages. This geological reality is called a karst landscape. It is the defining feature of this part of the world. And the Alapaha River, on its 202-mile journey from Georgia, has the profound misfortune of flowing directly across it. It is a classic losing stream. For most of its length, it behaves as any other river does. It drains a watershed of approximately 1,840 square miles, carrying tannins from decaying leaves that stain its water the color of black tea. But near the town of Jennings, the river encounters a part of the landscape where the underground plumbing system is exposed. This is the Alapaha River Sink, a feature known in geology as a swallet. It is, for all intents and purposes, a drain in the floor of the world. During periods of low or normal flow, the entire volume of the river is captured by this sinkhole. The water swirls into the earth and is gone. South of the sink, the original riverbed lies exposed for nearly 20 miles. It becomes a ghost river, a dry highway of sand and cypress knees that only comes back to life during extreme flood events. For generations, this vanishing act was a piece of local folklore. The Muscogee Creek people who first inhabited this land gave the river a name which is thought to mean other side, a possible reference to its elusive nature. Later settlers had their own theories. According to regional lore, they conducted their own rustic experiments, a low-tech version of a tracer study. They would throw logs, branches, or other buoyant objects into the swirling vortex of the sink, then travel downstream to the larger, more famous Suwannee River, and simply wait. They suspected a connection, a place where the lost water must surely re-emerge, days or weeks later. They would sometimes spot their marked debris floating in a different body of water altogether, a powerful spring boiling up from the ground about a half-mile from the Suwannee itself. It was compelling evidence, but it was not proof. The scale of the underground system was still a complete unknown. By the 1970s, Florida was changing. The state's population was booming, and with it the demand for fresh water. In 1972, the state legislature established 5 water management districts to oversee this critical resource. For the region of North Florida, that body was the Suwannee River Water Management District, or SRWMD, headquartered in Live Oak. Along with the experts at the Florida Geological Survey, a state agency founded back in 1907, these scientists were tasked with transforming folklore into fact. The question of the Alapaha River was no longer a simple curiosity. It was a critical water management puzzle. Was the water from the Alapaha truly feeding the Suwannee Basin through an underground route? And if so, how direct was the connection? How fast did it travel? This is the part that history now records as a landmark moment. In July of 1977, a team of geologists decided to settle the question permanently. Among them was Thomas M. Scott, a geologist with the Florida Geological Survey, who would become a leading authority on the state's karst geology. The plan was simple, elegant, and definitive. They would play a cosmic game of poo sticks, but with advanced chemistry. They brought 10 pounds of a specialized tracer dye called rhodamine, WT, to the edge of the Alapaha River Sink. Rhodamine WT is a fluorescent red dye designed specifically for hydrological studies. It is highly visible even at minute concentrations. It travels well in water, and it has low absorption to sediment, meaning it stays with the water it is tracking. The team poured the 10 pounds of vibrant crimson powder into the swallet. The dark river water consumed it, turning a shocking shade of red before plunging into the earth. Then, the waiting began. For days, nothing happened. The geologists stationed themselves 10 miles south at a large effervescent spring known as the Alapaha River Rise. This spring was the place local lore identified as the exit point. It is a first magnitude spring, a designation reserved for Florida's most powerful spring systems, those discharging more than 100 cubic feet of water per second. That is over 64 million gallons of water every single day. The rise is not a gentle seep. It is a forceful upwelling of clear, cool water that erupts from a submerged cave opening to form the headwaters of its own small river, the Alapaha Rise River, which then flows for a half-mile to join the Suwannee. The scientists took water samples day after day, analyzing them with sensitive fluorometers. They were looking for the faintest trace of that red dye, the signal that would confirm the underground highway. 1 day passed, 2 days, a week. And then, approximately 10 days after the dye was poured into the sinkhole, they got a hit. The fluorometers registered a spike. The clear water boiling up from the rise was now carrying the signature of the rhodamine WT. The dye had traveled 10 miles underground, navigating the dark, unmapped conduits of the Floridan Aquifer, and had re-emerged right where the old stories said it would. Tom Scott, the FGS geologist, later described the moment with clinical excitement. It was bingo, a complete success. The connection was no longer a theory. It was a proven fact, a closed loop. The Alapaha River did not vanish. It took a 10-day, 10-mile journey underground before being reborn as a spring, which then fed into the Suwannee River. This channel is all about exploring these hidden systems. You can subscribe if you want more videos like this. The 1977 dye trace study revealed a stunningly efficient natural plumbing system, one of the most dramatic examples of karst hydrology on the planet. Zoom out, and the true scale of this system comes into focus. The Alapaha River Sink is not just a hole in the ground, it is a direct, high-speed injection point into the Floridan Aquifer system. The Floridan Aquifer is one of the most productive aquifers in the world. It is not an underground lake or river in the conventional sense. It is a vast, saturated zone of porous limestone and dolomite rock, a subterranean sponge covering 100,000 square miles beneath all of Florida and parts of Georgia, Alabama, and South Carolina. It holds an estimated quadrillion gallons of fresh water and serves as the primary source of drinking water for tens of millions of people. This massive reserve of water is not static. It flows, albeit slowly, under immense pressure through the network of cavities and conduits carved out over millions of years. And the Alapaha River has found a main entrance. So the Alapaha is a river with a split personality. It has two different mouths. For most of the year, during low to moderate flow, it uses its subterranean mouth. The water disappears at the sink, travels through the aquifer, and exits at the rise to join the Suwannee. The original 20-mile-long surface channel remains dry. But during periods of heavy, sustained rain, often during tropical storms or an unusually wet winter, the volume of water flowing down from Georgia becomes too great for the sinkhole to swallow. The system backs up. The swallet's capacity is overwhelmed, and the river does something remarkable. It ignores the drain, the water level rises, bypasses the sinkhole entirely, and continues flowing south along its ancient original surface channel. The Ghost River comes roaring back to life, and the Alapaha finally merges directly with the Suwannee River miles downstream from the rise. It is like a train switching tracks depending on the volume of traffic. And this entire dynamic, this disappearing act, is not a sign of a broken river. It is a feature, not a bug. It is a system working exactly as nature designed it for thousands of years. The confirmation of this underground highway in 1977 solved the old mystery. It was a triumph of geological science. But here is the part nobody could have predicted. In solving that puzzle, the scientists uncovered a far more disturbing reality. The very efficiency of this underground connection, the speed at which water could travel from surface to spring, was not just a geological curiosity. It was a profound vulnerability. And the mystery of the Alapaha River began to shift. It was no longer about where the water goes. It became about what the water carries with it. Now, here is the part the headlines do not capture. The common misconception about groundwater is that the earth acts as a perfect filter. We imagine water percolating slowly through layers of sand and clay, being purified over decades before reaching an aquifer. In a karst system, that assumption is dangerously false. The water does not percolate. It flows. It travels through open, pipe-like conduits that can be dozens of feet in diameter. The travel time is not measured in years, but in days. As the 1977 dye test proved, water from the Alapaha River can reach the Alapaha Rise in just 10 days. This means there is almost no time for natural filtration to occur. What goes into the sink comes out at the rise, and from there it enters the Suwannee River and the broader Floridan Aquifer system. The Alapaha River is a hypodermic needle aimed directly at the heart of North Florida's water supply. This brings us to the new, stranger mystery. Over the past few decades, the water quality in the Suwannee River Basin has been in steady decline. In October of 2023, the Florida Springs Institute, a nonprofit science and advocacy group founded by Dr. Robert Knight, one of the state's foremost experts on spring ecology, released a devastating report. The Suwannee River Basin received a D grade. The primary culprit cited in the report is nitrate pollution. Nitrates are compounds of nitrogen and oxygen, essential for plant growth. In small natural concentrations, they are harmless. But in high concentrations, they become a potent pollutant, triggering explosive algal blooms that choke out native aquatic plants, deplete oxygen, and harm fish populations. The Suwannee River, made famous in Stephen Foster's 1851 anthem, Old Folks at Home, a song that created a national image of a pristine, idyllic waterway, is now facing an ecological crisis. And the Alapaha River's disappearing act is making it worse. The source of these excess nitrates is well documented. It is primarily agricultural runoff from fertilizers used on row crops and from animal waste at livestock operations. It also comes from septic tank leakage and wastewater treatment facilities. Across the 1,840 square mile watershed of the Alapaha, these compounds are washed by rain into the river. The river then flows south until it reaches the Alapaha River Sink and injects this nitrate-laden water directly into the aquifer. Some springs within the Suwannee River Basin now show nitrate concentrations 100 times higher than their natural background levels. Dr. Robert Knight has spoken with grim urgency about the situation. He has stated that nitrate levels are still rising, while water flows in the springs are declining. He describes the ecosystem as being in a state of collapse. The problem is that the agencies tasked with protecting these resources are often caught between agricultural interests, development pressures, and their environmental mandate. If you think more people should know about this, lightly tap the like button. Or send this to a friend. The Alapaha's Disappearing Act, once a charming piece of North Florida's identity, has become a demonstration of the aquifer's fragility. Every time the river pours itself into the ground, it is delivering a dose of pollutants directly to the system that provides drinking water to nearly everyone in the region. From small towns like Live Oak and Jasper, to the entire Tallahassee metro area of almost 400,000 people. The water that emerges at the Alapaha Rise at a constant 72 degrees Fahrenheit is no longer guaranteed to be pure. The mystery is no longer a question of geology. It is a question of chemistry and public health. The story does not stop there. The stakes ripple outward, amplified by larger forces. Climate change is altering rainfall patterns, leading to more intense periods of drought punctuated by more extreme flooding events. This directly affects the behavior of the sink rise system. A prolonged drought can lower the water table in the aquifer, potentially altering the pressure dynamics that govern the rise. An extreme flood event can wash a massive, concentrated pulse of pollutants from the entire watershed into the river and subsequently into the sinkhole. In a very short period, at the same time, North Florida is one of the fastest growing regions in the state. This increasing development puts more pressure on the Floridan Aquifer through increased water demand, while also adding to the pollution load through more pavement, more septic tanks, and more fertilizer-dependent lawns. It is a feedback loop of escalating risk. What was once a local wonder is now an environmental bellwether. The work done by Tom Scott and the Florida Geological Survey in 1977 was groundbreaking because it defined the physical pathway. It drew a line on a map between 2 points. Today, the work being done by scientists like Dr. Knight and organizations like the Florida Springs Institute is to analyze what is flowing along that pathway. The narrative has shifted from celebrating a natural wonder to sounding an alarm about an environmental threat. The very existence of the Alapaha River Rise Preserve State Park, established in 1997 to protect the 4,702 acres around the rise, is a testament to the recognized importance of this unique system. Yet, protecting the land around the exit point does little to stop the pollutants entering the system 10 miles upstream. The problem is systemic. The Suwannee River Water Management District is tasked with an incredibly difficult balancing act, ensuring adequate water supply for agriculture and urban populations while also protecting the health of the river and spring ecosystems. The 2023 report from the Florida Springs Institute suggests that, so far, that balance has not been achieved. In Dr. Knight's words, "We are not seeing the response that we need from our state agencies or from the polluters. The issue is that the pollution is non-point source. It comes from everywhere, from thousands of individual sources across a vast landscape, making it incredibly difficult to regulate and control." And so the quiet wooded landscape of Hamilton County holds a story that is far larger than itself. The disappearing river is a metaphor for a hidden crisis. It shows, in the most direct way imaginable, how actions on the surface have immediate and profound consequences in the hidden world beneath our feet. The romance of Stephen Foster's Suwannee River is colliding with the hard data of nitrate testing. The simplicity of a river vanishing into a hole has given way to the complexity of aquifer management. In the 21st century, the mystery has not been solved. It has evolved. It has become deeper, darker, and infinitely more urgent. Most people forget to subscribe after watching, so there's your reminder. We are left with a series of unresolved truths. The Alapaha River will continue to flow into the earth. The limestone conduits will continue to channel that water southward. The politicians and water managers will continue to debate the acceptable levels of pollution and the economic costs of regulation. So, 3 questions hang over the Suwannee Basin tonight. How much more pollution can the system absorb before the ecological collapse of its world-famous springs becomes irreversible? When will the political will emerge to address the source of the contamination, not just study its effects at the outflow? And what does it mean for the future of Florida when a natural wonder, a river that performs a magic trick, becomes a clear and present danger to the water we all depend on to live? The water that flowed past Jennings, Florida, this morning is right now, at this very moment, moving through the total darkness of the Floridan Aquifer. It is traveling at a speed of less than a mile per day, carrying with it a chemical signature of the world above. The Alapaha River Sink is still draining. The aquifer is still receiving its flow. And somewhere in the 10 miles of limestone between the sink and the rise, the future of the Suwannee River is being decided.